How are you, my friends? This video is presenting 9 old exams questions related to inequalities. There are 4 types here and 9 questions. Just some important remarks about inequalities. Decide first the type of inequality, then you will be able to do it. You can read all these 6 hints. Change the sign of inequality if needed when you multiply and divide by a negative number. If the LCD contains variable, do not multiply on both sides, remember? Make a table of signs if the inequality has a polynomial or rational. Split, make it 2, split the compound inequality if not linear. This is question number 5, you will see an example, and remove all the zeros of the denominator from the solution because they will make the denominator 0. Okay, let's see. Question number 1, linear. Solve the linear. We see here, the easy part is we have the denominators all constant. So 10, 5, 2, and there's a 1 over 1 here. So easily I can multiply by the LCD 10. So multiply all this by 10. So it will be 23 minus 23x. Multiply this by 10. It will be 10 over 5, 2. 2 times 3, 2 times 2x. 10 over 2 is 5, so there is a minus here. Remember, this is minus x and minus minus, so this will becomes here minus 25 because 10 over 2 is 5 multiplied by this. Remember this minus plus 10 times 1 is 1, 10. So that's easy now. I put all these x's together, minus 16x greater than minus 32. Divide by minus 16, change the sign. This is greater than becomes less than. So the solution from minus infinity until 2 open. That's the easiest question. Number 2 is a compound. So the compound, if it is linear, see x power 1 here, x power 1, and also we have in the denominator all constants, so that's easy compound. We'll see more in question number 5 where we need to split. So let's simplify this radical first. So minus square root of 81 over 100 will be minus 9 over 10. You see this one here, x plus 5, 1 over minus 5. Take the minus up here, change all the signs for sure. So minus x minus 1 over 5, make it positive easier. X over 10 minus 1 over 5. So we see the LCD is 10. So I multiply by 10, 10, 10 each term. So 10 here will be cancelled. So minus 9. 10 over 5 is 2. So this is minus 2x minus 2. 10 over 10 is cancelled. So there is an x. 10 over 5 is 2. And with the minus, minus 2. Now, minus x minus 2 between minus 9 and minus 2. Remember, this is open. This is closed. There is no equal, there is equal. Let's add here 2 on each side. So we add 2, we get 0 here, minus x, and then minus 7. Divide by minus 1. Change both signs. So 7 greater than x, greater than or equal to 0. Rewrite it. It's the same here. Rewrite it. We say x greater than or equal to 0, less than 7. That's the same meaning. So this one is easier to write in an interval and graph it here. 0 closed until 7 open. That's the solution. Now, number 3, we said here important. Solve the polynomial inequality. See, this is x power 4. But never, please, never, never multiply this. Never expand. Because you know the rules. If you want to know the rules and simple examples, you can go to lecture 25, please. This is about inequalities. Algebra course, lecture 25. We never multiply. If we have like this, we need to factor, but we have to have 0 on the right side. So here we factor more. See, we factor more. That's the question. Factor this one, x minus 2, x minus 3. Factor this one, x plus 1, x minus 2. Now we notice here, x minus 2 is the same, so we make it squared. Now, After we completely factor, we find all the zeros. Remember, the zeros are not the solutions. These are the numbers that will make each factor 0. It will help us to make the table. So that's 2, that's 3, that's -1. I put it here, -1, 2, and 3. Make sure that you put the numbers in order. And then I put here all the factors like they are, x minus 2 squared. See, once I see squared or power 4, power 6, and even, I put all plus, 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 plus. Whatever number I take here, it will be on the table plus. Now, x minus 3, it will change. X plus 1, it will change. So what do? We take a number from here, from minus infinity to -1. Any number you like, let's say -10. So this becomes minus and minus. Between -1 and 2, I can take, let's say, 0. So this would be minus and plus. Between 2 and 3, I take 2.5. It would be minus and plus. More than 3 until infinity, I take 100. And then you put it in the x. See, when you multiply all these, this is the result here. We call it plus, minus, minus, plus. We look at the question here, the last inequality, less than 0. So I have to choose the minuses here. Minus and minus. Why I don't say -1 to 3? See all this minus. Why I don't say the solution -1 to 3? You know why? Because if I put 2 in here, it will be 0 on this side. You see, if I replace 2, one of the zeros, it will be 0. 0 less than 0? No. Because we don't have an equal. So we have to make -1 to 2 open 2 to 3. That's the final solution. Now find the values of the k for which the given equation has non-real complex solution. This one is quadratic here, 2x squared minus 4x plus k is equal to 1. Also this one another quadratic equation, power 2. We are saying in the question that the solutions are complex, not real. So you have to think of what? Discriminant, remember? Discriminant is less than 0. So that's the whole idea here. So this is the equation. Remember, look at the equation here. K is equal to 1. So you have to bring k minus 1. See, this is C. And B is the -4. A is the 2. It's very important to find out the correct A, correct B, correct C. Now, complex solution, discriminant less than 0, we know that. B squared minus 4AC less than 0. Put all the numbers, look what we get here. 16 minus 8k plus 8 less than 0. This is a linear. See, the decay has power 1. That's a linear, so no need for table of signs. So minus 8k less than minus 24, divide by minus 8 and change the signs to k greater than 3. See, we need the values of k from 3 to infinity. So here A is 2, B is k minus 1, C is equal to 2. Same idea, complex solutions, discriminant less than 0, B squared minus 4AC less than 0. The only difference between B and A is we have in the inequality here, k squared. K minus 1 squared minus 16, we can factor this difference between two squares. So it will be k minus 3, k plus 1 less than 0. So we need table of signs. So we put here minus 3 for the k and then 5 for the zeros. Just make a table of signs that we choose the negative between minus 3 and 5. Question number 5. I think it's an important question. This is a multiple choice. The solution set of this is equal A or B or C or D or E. We see here, it's a compound. You see, we do inequalities. But in this compound, we have quadratic or polynomial degree 2. So we have to split. This is the idea of splitting. Look at this nice diagram here. This is the question. 0, you see 0 less than x squared minus 4 less than or equal to 5. If this is linear, see, if linear, no need to split, like x minus 4 to x minus 7, whatever. Split into two polynomial inequalities. solve each one separate, the red and yellow, and then find the intersection. That's the hint. So we split it now. Look at this nice here. We split and put and. When you split here, you put and. 0 less than x squared minus 4 and, which means an intersection, x squared minus 4 less than or equal to 5. This is open, you see here. This is closed. It's a nice question, actually. This one, x squared minus 4, that's polynomial or quadratic inequality. So we have to factor x minus 2, x plus 2 greater. See, this is greater than 0. You can write it 0 less than that, or this one greater than 0. Find the zeros, make small table minus 2 to 2, and then choose the positive minus infinity to minus 2 union 2 to infinity. We call this solution 1. Now let's see the second one, x squared minus 9, factor it. X minus 3, x plus 3, the zeros are 3 and minus 3, make another small nice table, choose the negative, closed, that's solution 2. Now imagine here, you take solution 1 and solution 2, find the intersection. I made here a little diagram for you. So minus 3, minus 2, 2, 3. See this solution 1 here on the top, until minus 2 union 2 to infinity. Solution 2 down, closed, see closed. Find the intersection. So it will be closed minus 3, open minus 2 union, because we have two intersections here, two parts, 2 open to 3 closed. The answer is D. Please study this one, try to understand it, and do it more than one time. Question number 6 is normal rational, but remember here, big mistake students can do if they multiply by the LCD. Now, any variable in the denominator, you cannot do anything. Just bring it on one side here. Bring it on one side, greater than 0. And then rearrange it. And then combine on the left side here. Combine this. 1 over x squared minus 1 over x. So multiply here x and x. So it becomes 1 minus x over x squared, greater than 0. Do not multiply on both sides, but you can combine on one side. So as we mentioned before, we have seen this x squared. X squared, put all positive on the table. 1 minus x. Remember, choose a number here. Let's say minus 10. It will be plus. Between 0 and 1, take half. It will be plus. And then greater than 1, let's say 7. It will be minus. So when you multiply here or divide, this is plus, plus, and minus. What are the solution here? The plus. See, we check the 0. Is 0 in the solution here? 0 will make the denominator 0, so we will take it out. So from minus infinity to 0, open union, 0 to 1, closed. Now check here, if you want to check. Is 1 in the solution? Put 1 here. 1 minus 1 over 1 squared. 0 greater than or equal to 0? Yes. So 1 is closed because we have equal there. Question number 7, same idea as number 6, but different question. Solve the rational inequality. X squared minus x minus 7 over x squared minus 1 less than or equal to 1. Remember, we have a variable in the denominator. The only thing you can do, bring this one here, minus 1, less than or equal to 0. And then combine on the left. You see here it said combine. Combine on the left. See, this is the left side here. X squared minus x minus 7 over x squared minus 1 minus 1 here. So combine on the left. That means multiply up and down by x squared minus 1. Just combine like we did in lectures 2 in the past. So this becomes here with the minus x squared plus 1. Make sure you understand this. Now simplify, cancel this one. Minus x minus 6 over this one, we can factor here. X minus 1, x plus 1. Remember here, you can leave it like this and do the table. You see this one here? Or if you have many minuses, you can multiply with minus on the right, on the left, only minus, change the sign. If you do a table for this, the table will be different, but the final solution will be the same. If you multiply with the minus, this becomes plus, but you have to change the sign. So now the question becomes, easy question, x plus 6 over x plus 1, x minus 1 greater than, remember, change the sign. If you don't change the sign, you get wrong answer. Now you make a table, big table. We have done many tables now. For this, for the last one, choose the plus. Also, if you want to learn more, make a table for this. For this one here, minus x minus 6. And choose the negative. It will be the same solution here. And remember, there is in the denominator 1 and minus 1. So we cannot accept 1 and minus 1. We make them open. Okay, I will remind you, if you need to see more examples and explanation, go to lecture 25 in the algebra course. Well, this is not easy because it has 3 terms, 1 minus 4 over x. Even the answer, I think, a little tricky. Now rearrange the inequality, move all the terms on the left less than or equal to 0, even if we have greater than or equal to 0, it's the same. Again and again and again and again, I would say the most important advice here, never multiply on both sides inequalities if the LCD contains any variable. Instead, you have to combine terms on the left, combine it. You can add and subtract on the left, but never multiply on both sides. Now the LCD, we can see here x minus 1. See, the first one is 1, so we need x minus 1 up and down. And here we have minus 4 over x, so we need only x minus 1. The last one we have 1 over, see this is plus now, 1 over x minus 1, I multiply by x over x. So I have all the same denominator here, x minus 1. This one becomes x squared minus x, and this one minus 4x plus 4 plus x. Plus x minus x cancelled. I have x squared minus 4x plus 4, which is perfect squared. Now look at this nice here. X minus 2 squared over x minus 1 less than or equal to 0. Ready to make the table on the next slide. You can do it and then you can check if you like. X minus 2 squared x minus 1 less than or equal to 0. So we make the table now, find the zeros, it's 0, 1, and 2. And then I put x minus 2 squared, I put all plus here. X means x minus 0, or we can leave it as x minus 1. You can take here any number, let's say minus 7. So this is a plus, this is a minus, this is a minus. Between 0 and 1, you can take half. This is all plus, the first one, see, squared. 1 and 2, you can take 1.5. So that's all plus. And greater than 2, it's all plus. Now, what do we need? Less than 0, the negative. Where is the negative? 0 to 1. See? 0 to 1. And we cannot accept, even if we have equal here, we cannot accept 0 as closed. We cannot accept 1 as closed. See, that's not the final answer. 0 to 1 open. It should be open. Union 2. Why 2? Because 2, one of the zeros I have to check here. 2, one of the zeros. If I put 2 here, 2 minus 2 squared over 2 times 2 minus 1. So it becomes 0 less than or equal to 0. There's an equal, so I have to include 2 in the answer. If I have only less than, 2 is not there. If I have only less than, that's the answer, 0 to 1. Now, the last one, question number 9 is nice. It's already factored here. X minus 1 cubed, x squared plus 10x plus 25 all power 6, power 17, power 18. I put these big numbers on purpose to tell you what we can do. This one is already factored, x minus 1. Never try to expand. This one power 17, this is power 18. This one try to factor more here. X squared 10x plus 25. It would be x plus 5 all squared. Power 6 becomes 12. Now look at the question here. The zeros are minus 5, minus 2, 1, and 2. So there are 4 zeros. I make big table. Look at the trick here. X minus 1 cubed. See, that's cubed. We look at the sign. We need the sign. The sign of this cube is the same sign as x minus 1 because it's an odd power. So any odd power, you can treat it as power 1 in the sign, not in the value. And for even power, see x plus 5 power 12. How can you deal with that? This is the same as squared because it's an even. And the same thing, 17 is an odd, 18 is an even. So x minus 1, you see x minus 1 instead of x minus 1 cubed. Power here, x plus 5, power 12. So x plus 5 squared here. X plus 2, power 17, that's an odd, so x plus 2. X minus 2, power 18, x minus 2 squared. So these are all pluses, you see, plus, 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 plus. For this one, they change. I have to choose a number. But remember, we have here 1, 2, 3, 4. 4 zeros we have. That means we have 5 intervals to check. This is 1, minus infinity to minus 5. Another one, another one, another one, another one. Now we have to check for sure here because we have greater than or equal to 0. We cannot accept 2 here. See, we cannot accept 2. If you make the table and finish it, we choose greater than or equal. See the question here, greater than or equal. So we choose the plus. So the plus becomes from minus infinity to minus 2, including the minus 5. Let me check here. Minus 5, if I put it there, it will be 0 greater than or equal to 0. Yes, we accept minus 5. So it will be included here. And there is another plus here, 1 to 2 open, union 2 to infinity. If I put 2 in the denominator here, 2 minus 2 is 0. So I cannot accept it. So that's why we have to make open at 2. That's the final answer now. Now just to modify question 9, little modification here. Modify question number 9. This is question number 9 exactly here. Change greater than or equal to greater than. The answer will change. Try to figure it out. Almost the same table. See, the same table, same zeros, same question, only from put greater than, not greater than or equal. And go to the table of question number 9. We see here, we cannot accept minus 5. Because if you put here minus 5, it will be 0 greater than or equal to 0, which is not acceptable. So the final answer for this modification, minus infinity to minus 5, open, union minus 5 to minus 2, open, 1 to 2, open, 2 to infinity. Little change. Now, these are the answers. If you want to see more examples and the explanation of please go to the lecture 25, as I mentioned before, in the algebra course. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Thank you very much. See you in another video with another topic. Thank you, guys.